So update's going to be pretty similar to lookup. So let's start by copying that code and see how we need to change it. So we had lookup. We're going to change it to be update. Now instead of just taking a key as its input, it's going to take a key and a value. But it's not going to return anything. So we're going to get rid of the returns, right? Remember, all update is doing is modifying the value of the entry. So now we still have what we had for lookup. We're still getting the bucket, and we want to do that. We want to make sure that we update the value in the right bucket. We still need to look through the entries in the bucket to find if one matches. If we find one that matches, well, what we did in lookup was just return it. In update, what we want to do is change the value associated with that key. So we're going to have an assignment that replaces whatever value was there before with the new value. And now instead of returning the value, we want to stop going through the loop. And we actually are done with the update. So we can return here. We found the entry. We updated the value. We also need to deal with the case where we didn't find the entry. So now we've gone through the loop enough times. When it was a lookup, we just returned none. When it's an update, what we want to do when the key is not already in the table is add it. So now we're going to use append to add a new entry to bucket that has the key and the value. So that's how we define update. There's certainly lots of other ways to do it. And one thing you should be thinking about is, well, this is actually very similar to lookup, right? We duplicated a lot of code. Maybe there's a way to define update and lookup so we don't have to have two copies of the code that scans through the bucket to find the right entry. We'll leave that as a homework question for this unit. For now, we're going to be happy that we've got correct implementations of both lookup and update. And let's test them. So what we did before, we're going to replace the adds with updates. And now the second time, what happened with the add was we added an entry, but we could never reach that entry because it had the same keyword. Now we've used update. The second time, we should be updating that value, and we'll see that the lookup now produces the value 27 for the second lookup. That's good, right? The first time the value was 23. We did the update, we got 27. And we can see that the bucket only contains one entry. So this is great. We finished our implementation of the hash table. We can do updates that will either add new values to the hash table if they don't already exist, or change the value of ones that exist. And we can do lookups, and the lookup will know where to look, which bucket to look in to find that key if it exists. So this has the great property that as the number of keys increase, as long as we increase the number of buckets accordingly, the time to do both an update and a lookup is constant. This means the time doesn't increase even as the number of keywords increases, as long as we increase the number of buckets. So the size of each bucket stays the same size, because the expensive cost of this is going through the elements in the bucket looking for the key that matches.